Welcome to qnawire.
Well, I was recording this problem and I ran out of space on my iPad, so now I'm just going to record it. I've written everything down, and there's no possible way I'm writing this down again, so you can look at this and see what it is. So problem 225, same conditions and we're asked to find the acceleration of slider B at 425 millimeters. So I've written all of the information that I know right here, and I've drawn a less than gorgeous diagram here. And actually, I had calculated some of this. Here we found our length of AB, and there's how to do it and what I got. And I actually went to 2 decimals a little later than this. Here's my length of AC and how to calculate that. And that's where some of these values are coming from. My HAB, how to find it, and what we've got. So those are my values that I'm using. And 1,000 millimeters equals the sum of the squares, the square root of the sums of the squares of SA and H2 plus H squared AC and SB squared and HAB squared. We derive this with respect to time. So you can see, just check this whole equation out. And knowing this, then we did some more work here to get equation 7. This is equation 7, which we'll work with later. Plugging values into equation 7, we end up with negative 62.85 millimeters. I see I forgot a parenthesis right there. Then we derive equation 7 with respect to time. There it is. That was a huge deal. That's a huge derivation. Take a look at that. You'll probably have to stop if you're copying this down. And then SA equals SB equals 0 with the doubles, so the rod's not accelerated. And I plugged values in here. This was a bear to write down. This whole thing goes on, and way down here, I solved it. This is all the equation. And I'm pretty sure I went through and got this correct, but it's so easy to make a little tiny error here. But this is what I got. I hope it's good.